When we look out at the cosmos, we see this absolutely breathtaking structure, right? This cosmic web of galaxies and voids. And for a long, long time, we thought we had a pretty good handle on how it was all built. But it turns out there's this deep tension in the story of creation, a conflict that a fascinating new idea might just be able to resolve. Okay, let's dive into this.
All right, so to really get the new idea, we first have to understand the old one. We're going to start with what's called the standard blueprint. This is the consensus view on how the universe was built, a theory that honestly has served science incredibly well for decades.
So the core idea has always been something called bottom-up hierarchical growth. It's actually really simple and elegant. Tiny little clumps of gas merge to form stars, and then those stars cluster into galaxies, which eventually group up into the massive clusters we see today. You can think of it like building with cosmic Legos, small pieces first, building up to bigger things. And this model is brilliant, absolutely brilliant, at describing the later, more local universe that we see around us.
But that simple, elegant story has started to show some pretty serious cracks. And that brings us to this next part, a glitch in the cosmos, all thanks to what the James Webb Space Telescope found when it peered back to the very dawn of time.
And here it is. This is the breach in that standard model. The James Webb started seeing things in the super early universe, we're talking the first billion years, that just shouldn't exist yet. Mature, massive galaxies, and these early supermassive black holes they've nicknamed little red dots, which are just enormous for their age. And here's the crucial point. Under that strict bottom-up model, there just wasn't enough time. The clock simply hadn't ticked long enough for these things to grow that big.
Let's just zoom in on black holes for a second, okay? The standard theory says they start from the seed of a collapsed star, and they grow slowly, patiently, through mergers over billions of years. But JWST is finding these absolute monsters that seem to have appeared almost ready-made, nearly instantly. The timeline just doesn't add up. It's impossible.
And it's not just the black holes. We're seeing whole galaxies that are too compact, too bright, and way, way too soon. At the same time, those huge empty spaces, the cosmic voids, they look like they've been cleared out much, much faster than gravity alone could ever manage. The old blueprint, it's just clearly failing when we look back at the earliest cosmic times.
So what do? Do we just throw out this old theory that actually works so well for the later universe? Well, maybe not. As we're about to see, the solution might be to look beyond a false choice. What if the universe uses two blueprints at the same time?
See, for years, the whole debate has been stuck between these two extremes. Either everything builds up from small to large, or everything starts large and then breaks down into smaller pieces. But this illustrates the core mistake so well. The assumption that the universe had to choose just one algorithm and stick with it for its entire history.
This quote right here, this gets to the very heart of the new idea. The universe isn't rigid or dogmatic. It's fundamentally adaptive. It's efficient. It just uses whatever method is most physically efficient for the conditions at hand. It's a pragmatist.
So how does that actually work in practice? Well, in this section, we're going to use a really powerful analogy to explain this dual mode principle. I want you to think of it like a cosmic construction project, one that needs two very different roles, the architect and the builder.
So let's break down these two modes. First, you have the architect. The architect works top-down, going from large to small. This mode dominates early on to build the cosmic scaffold, the big framework. Then you have the builder, who works bottom-up, going from small to large. This mode takes over later in the universe's life to lay the bricks and fill in all the details.
Okay, so first up is the architect. In the really early high-energy universe, massive gravitational sinks, like those impossible black holes we saw, they formed directly from space-time instability, not from collapsed stars. They rapidly set up the boundaries of the voids and the filamentary networks. And what's the result? The container for future galaxies is built before the galaxies themselves even exist. The framework comes first.
Then, once that scaffold is in place, the builder gets to work. Inside this pre-existing architecture, standard physics takes over. Gas cools, gravity starts to act locally, stars ignite, planetary systems form. This is that familiar bricklaying process that fills in the grand design with all the detailed structures we know and love.
So let's put it all together. What does this new picture of our adaptive universe actually look like? Well, in this final section, we're going to see how this dual-mode approach creates a much more complete and, frankly, coherent story of cosmic history.
This chart just visualizes the whole idea perfectly.
Right at the beginning of cosmic time, the top-down architect is in charge, getting the big stuff done really quickly. But as the universe evolves and cools, its dominance fades, and it kind of hands off the primary role to the bottom-up builder. It's not like a hard switch, they coexist and work together, with their influence just shifting over billions of years.
And look, this isn't just some nice story. It elegantly solves the observational puzzles we started with. Those massive early galaxies that shouldn't exist? Well, they're explained by the top-down mode, building the scaffold first. Those early supermassive black holes? The model calls them primary sinks, massive gravitational wells that form directly from spacetime itself, not from stars. This dual-mode framework just maps so cleanly onto the data, and it resolves all that friction we had with the standard model.
So, why does all this matter? Well, it reframes our entire understanding of the cosmos. Our universe isn't rigid. It's not blindly following a single algorithm from the Big Bang to today. It's efficient. It's adaptive. It builds the scaffold and then it lays the bricks. It does what works.
What's so cool is that we resolve this huge cosmic crisis not by inventing new particles or exotic, weird forces, but just by abandoning an old artificial assumption that the universe had to choose only one way to build itself. And that leaves us with this final, kind of tantalizing question. If the universe is this flexible, what other fundamental rules are we assuming that might not be rules at all?